Hello, everyone, and welcome. I'm excited to have you here today. Our presentation is titled Evolution of Robots and Laws of Robotics. We'll take a fascinating journey through the history of robotics, from ancient dreams to cutting-edge AI machines. Along the way, we'll also explore the ethical principles that help guide their development. So, let's dive in and discover how robotics has evolved and the important laws that shape their future. Let's take a journey through the fascinating history of automation and artificial beings. Starting back in 320 BC, Aristotle envisioned tools that could operate on their own, which was truly revolutionary for his time. He imagined machines that could work independently, reducing the need for human apprentices or slaves. This idea laid an early foundation for autonomous tools. Moving forward to 1495, Leonardo da Vinci sketched designs for a humanoid robot, centuries ahead of his era. His drawings showed a mechanical figure capable of performing human-like actions, demonstrating an incredible foresight into robotic possibilities. Then, in 1737, Jacques de Vaucanson built the flute player, which was the first biomechanical automaton. It could play 12 different songs, showcasing how complex and lifelike machines could become. Finally, in 1920, the term robot made its debut in Karel Čapek's play RUR, derived from the Czech word robota, meaning forced labor. This marked a pivotal moment where the concept of robots entered popular culture and language. These key milestones highlight how early dreams and innovations laid the groundwork for the advanced robotics we see today, connecting our past imaginings to our current technological reality. Let's take a closer look at the birth of modern robotics, starting with the foundational period of the 1940s. In 1941, Isaac Asimov made a huge impact by introducing what we now call the 3 laws of robotics in his short story, Liar. These laws set the groundwork for thinking about how robots should interact safely with humans. Then, in 1948, Norbert Wiener published Cybernetics, which explored control systems in both electronic and biological contexts, really laying the foundation for understanding how machines could mimic some aspects of living systems. The following year, William Gray Walter developed Elmer and Elsie, which were some of the earliest battery-operated robots resembling tiny tortoises. They could navigate their environment and responded to light, showing that robots could have simple autonomous behaviors. Moving into the 1950s and 1960s, this was a period of major breakthroughs. In 1950, Alan Turing proposed the Turing test, which became a key concept in evaluating machine intelligence, essentially asking if a machine could imitate human thinking convincingly. Then, in 1961, we saw the first robotic arm at General Motors, capable of lifting and stacking metal parts, an important step toward industrial automation. And just a few years later, in 1969, the Stanford arm was invented. It was the first computer-controlled robot with 6 joints, giving it a greater range of motion and precision. All these milestones connect to our overall theme, how early ideas and innovations laid the foundation for the advanced robotics we see today. Let's take a moment to look at some key milestones in the AI and automation era. In 1972, we had Shaky, which was the first robot capable of using artificial intelligence to observe its environment, plan its actions, and carry out tasks on its own. This was a huge step forward in autonomous systems. Moving ahead to 1985, we saw the development of medical robotics, with the Puma 560 performing the first documented robot-assisted surgical procedure. This showcased how AI and robotics could revolutionize healthcare. Then, in 1997, we have Sojourner, the Mars rover, which landed on Mars and sent back an incredible 2.3 billion bits of data along with 17,000 images. These milestones highlight how far AI and automation have come, from basic autonomous robots to advanced systems exploring other planets, demonstrating their expanding role in both industry and scientific discovery. Let's take a look at the consumer robotics revolution and how it really started gaining momentum. Back in 1998, we saw the introduction of Furby, which was more than just a toy. It was a robotic pet that could learn languages over time, creating a sense of interaction and personality. This innovation led to incredible sales, with tens of millions of units sold worldwide, showing just how eager consumers were for intelligent robotic companions. Then, in 1999, Sony launched Abo, their AI-powered robotic puppy. What made Abo special was its ability to react to sounds with pre-programmed behaviors, making it feel more alive and responsive. It was a step forward in making robots that could interact naturally with people. And by 2002, we saw the emergence of the Roomba from iRobot. This little vacuum was the first household robot to achieve commercial success on a large scale. It demonstrated that robots could be practical and helpful in everyday life, not just toys or prototypes. These milestones highlight how consumer robotics evolved from novelty to essential household devices, aligning perfectly with our theme of how robotics are transforming daily living. Humanoid and autonomous systems have really pushed the boundaries of what robots can do. In 2000, Honda introduced ASIMO, which was a major breakthrough because it could move naturally, mimicking human motion quite impressively. Then, in 2013, Boston Dynamics came out with Atlas, a humanoid robot featuring 28 hydraulic joints, and it even performed backflips, showing how advanced and agile these systems are becoming. Moving to 2016, Hanson Robotics created Sophia, who made history as the first robot citizen, thanks to her ability to recognize faces and express emotions. And more recently, in 2021, Cruise conducted its first robotaxi test rides in San Francisco, marking a significant step toward autonomous transportation. These innovations really highlight how humanoid and autonomous systems are transforming industries, making them more efficient, safer, and more integrated into our daily lives. Let's take a look at the 5 generations of robots and see how they've evolved over time. First, we have the first generation. These were basic mechanical arms that performed repetitive tasks. Think of them as simple, open-loop systems with no awareness of their environment. They did what they were built for, but couldn't adapt or learn from their surroundings. Moving on to the second generation, we see the emergence of learning robots equipped with sensors like radar, vision, and touch. These robots started to incorporate closed-loop feedback systems, which became more common in the 1980s. This means they could sense their environment and adjust their actions accordingly, marking a significant step forward. The third generation brought us sensorized control robots. They had artificial vision and could be reprogrammed via computers, allowing for a better understanding of their environment. This made them more flexible and capable of more complex tasks. Next, the fourth generation introduces intelligent robots that have mobility and can make instant decisions. They use technologies like fuzzy logic and neural networks, enabling them to handle situations that require quick judgment and adaptability. Finally, the fifth generation represents the pinnacle, advanced AI systems capable of automated learning. These robots can adapt to unpredictable environments without any human intervention, truly mimicking a level of intelligence that was once thought impossible. Throughout this progression, we see a clear trend, from simple, repetitive tasks to complex, autonomous decision-making. This evolution is at the heart of how robotics continues to transform industries and our daily lives. So, what exactly is robotics? Robotics is the fascinating engineering field that focuses on designing, building, and operating robots. It's a multidisciplinary area that combines mechanical systems, sensors, actuators, microprocessors, and communication tools to create machines that can perform a variety of tasks. Now, if we look back in history, we find a real pioneer, Al-Jazari. He's often called the father of robotics because he documented around 50 mechanical inventions, including the crankshaft, programmable automaton, and even a humanoid robot. His work laid the groundwork for many of the robotic innovations we see today. Fast forward to modern times, robotics is everywhere. We see robots transforming industries, whether it's in manufacturing lines, helping in healthcare, exploring outer space, or even assisting us at home. These robots are changing the way we live and work, making processes more efficient and opening up new possibilities. Throughout this presentation, we're exploring how these advancements connect to the broader theme of technological progress and innovation, showing just how integral robotics has become in shaping our future. Let's take a closer look at Asimov's 3 laws of robotics. The first law is all about safety. A robot may not injure a human being or, through inaction, allow a human to come to harm. This sets the fundamental priority for all robotic actions, to protect people above everything else. Moving to the second law, it states that a robot must obey orders given by humans, but with an important caveat. If those orders conflict with the first law, then the robot must override them. This ensures obedience while safeguarding human safety. And then there's the third law, which emphasizes self-preservation. A robot must protect its own existence, but only as long as doing so doesn't conflict with the first or second laws. This creates a balance between self-interest and the overarching priority of human safety. These principles were introduced in Asimov's 1942 story, Runaround, and they form a clear ethical framework. They really highlight that, in designing intelligent systems, human safety always takes precedence. This helps us understand how to think responsibly about robotics in our broader technological landscape. The future is now, and it's incredibly exciting to see how far robotics have come. In 2020 alone, over 384,000 industrial robots were shipped worldwide, primarily for manufacturing and warehouse operations. That's a huge number, and it highlights just how integral robots have become in our industrial landscape. We've been progressing for more than 70 years, moving from simple, repetitive tasks to highly adaptive, AI-powered systems. This evolution has transformed entire industries, making processes more efficient and opening up new possibilities we couldn't have imagined decades ago. Think about it, each new generation of robots has brought unprecedented capabilities and intelligence. We're now at the 5th generation, with machines that are smarter, more versatile, and more capable than ever before. Robotics has truly evolved from ancient dreams of mechanical helpers to sophisticated AI systems that can learn, adapt, and operate in complex environments. As technology continues to advance, robots are becoming more capable, more efficient, and more seamlessly integrated into our daily lives. And importantly, this progress is guided by strong ethical principles, ensuring that as robots become more capable, they do so in ways that prioritize human safety and well-being. So, the journey from those early dreams to today's advanced AI systems is not just about technology. It's about creating a future where robotics work hand in hand with us to improve our world.